here has used Scratch? Okay, so not enough hands going up, not enough hands going up. Scratch is developed by a group of people working at MIT's Lifelong Kindergarten project. Kindergarten is a word with particular significance to us here at Roehampton. I don't know if you realised, but we're in Frobel College at the moment, and Friedrich Frobel was the man who invented the notion of the kindergarten and this wonderful idea of providing a rich environment through which children can learn through exploration, play and discovery, and facilitating that learning rather than lots and lots of teaching. So, Scratch is just brilliant building block programming. We work with sort of Lego blocks or Frobel blocks, I suppose, click them together and produce something which is really exciting. It's a very, very straightforward way into programming. But where do you go from that? Those of you who have been following the sort of politics of this will have heard the Secretary of State saying 3 weeks ago now that by the time a child leaves primary school, they ought to be able to do simple animations in Scratch. And by the time they leave secondary school, able to produce their own iPhone apps or smartphone apps. Well, you know, year 3 is doing animations in Scratch already. You know, the learning curve is a really, really nice, gentle one for Scratch. I reckon by the time a child leaves primary school, they ought to be able to produce a reasonably straightforward, reasonably simple app for a smartphone. So what I'm going to do is show you how to do that using another tool supported by MIT. This is not Scratch. This is a thing which Google produced called App Inventor for the Android platform. But now Google have sort of open sourced that, and MIT have taken over the project. And so this is running over, at the moment as a private beta, experimental.appinventor.mit.edu. Sign up and they'll send you an invite and have a go at the thing. I'm going to start a new project and we're going to call this ball bearing. I hate doing live demonstrations. Ball bearing already exists, okay? Ball bearing. I did practice this, you see. I've done ball bearing 2 already exists. Okay, ball bearing 3. So it's looking already a little bit more complicated than Scratch, those of you who know Scratch, because we've got a 2-stage process here. Firstly, we assemble all of our resources down the side over here. So I'm going to need a canvas on which we can draw and move and largely have our being. If I just move James over to the side there, the width for this canvas I'm going to have as big as I possibly can, all the way across. And the height for this canvas, what do you reckon, folks? 400 pixels? Don't hurt anybody. There we go. So we've got some space in which we can work there. What else are we going to put onto our canvas? We are going to put a ball bearing, which there's all of these lovely, lovely tools there. I'm going to go straight into animation and drag the ball bearing across onto the canvas. And we can change that so that instead of black, it's a rather subtle dark grey. Click. And we can rename that, James Lynch is getting in the way again. And we're going to call that just ball. All that numbering stuff. Okay, let's have another ball over here. This isn't actually going to be a ball. You can design your own sprites just as you can in Scratch. You don't have to go with just dull balls here. Let's go for 15 pixels across for that one. That's a large black hole into which my little grey ball bearing is going to land. You've got access to so much of what your Android handset can do. So look on the social tab here. We can do things with Twitter. We can do things with the whole phone business. We can start sending text messages within the control of the program. We've got access to the sensors. I'm going to use the accelerometer sensor here. So I'm just dragging that one across, and that adds that on. Notice it's done as a non-visible component down the bottom here. We can control Lego Mindstorms robots. Anybody done anything with Lego Mindstorms? You can use your Android phone as a remote control for your Android robot again, sort of chasing things around the house. Why not? Wherever I go, James Mitchell keeps turning up. Okay, we have other stuff down here. Look, we've got access to the barcode scanner and all of the Bluetooth stuff. This is going to take us too long if we start playing with all of that this evening. So I've got something which is looking about right for me. Open the blocks editor. This is a little Java web start thing. This is going to take a little bit of time whilst this loads, downloading the application. All of these components you can are now open source, so you can host those on your own web server if you're not wanting to use MIT's private beta at the moment. So what have we got here? We've got the usual sort of Scratchy type, a little bit more complicated than Scratch, building blocks for this sort of thing. We have some special ones for the things which we've been using. So let's start with the accelerometer sensor. Just drag that across here. When the accelerometer sensor is changed, store some numbers, the X acceleration, the Y acceleration, and the Z acceleration. What do we want it to do? We want it to do something with the ball, and I want it to move the ball. So move the ball to a new x coordinate, a new y coordinate. Well, the new x coordinate is going to be made by taking the current x coordinate and taking away something, and the new y coordinate is going to be the old y coordinate, add something. A little bit of play and experimentation, you figure out exactly what's going on there, but I'm not going to go into that now. So where is the ball at the moment? We have some variables set automatically here. The old x coordinate, where is the ball at the moment? The old y coordinate, and then we're going to take away the x acceleration and add on the y acceleration. Don't ask me why the signs work in a different order. I suspect there's a very sound mathematical reason which people at Google and MIT would understand, but I wouldn't pretend to. What else are we going to need? Well, this game as it is at the moment, we've just got the ball rolling around the screen. Let's make it a little bit more exciting. Ball 1, which I failed to rename as the hole, when ball 1 collides with the other ball, oops, sorry, didn't mean to shout. We want something interesting to happen. What we're going to do then is move the holes. So we've got those move instructions somewhere. Ball 1, and ball 1 is touched. I want to move ball 1 to a new coordinates, and those we're going to calculate randomly. So this is going to be times something. This is going to be times something. What is it going to be times? The x coordinate is going to be based on how wide the canvas is. Canvas width. And the y coordinate, I hope people are thinking back to the GCSE or primary school, Key Stage 3 mathematics. Oh, I've taken the wrong thing, just put it in the bin. See what I mean about live demonstrations? Canvas 1. Canvas 1 height is what I'm looking for. There we go. And these can simply then be random fractions between 0 and 1. So that should put us into a random position somewhere on the canvas when the ball hits the hole. So far so good? Do you want to just pause for a moment and figure out what's going on there whilst I take my mobile phone, which happens to be an Android phone. Other phones are available, but they won't work with this. And plug that into the router. And is the camera picking this up?
Yes, it is.
Yeah, okay. Okay, it says companion software, not interested in that. Okay, that's my stopwatch, which I think you would have failed to get going at the start. I'm hoping, oh yeah, and then I've got to do connect to device. Okay. And we have a little yellow thing here. What about these Android phones? Will you be able to get a set in school so that everybody in Year 6 could have a go with one of these? I have people shaking their heads here. There is an emulator. You can do all of this on the desktop. So I've got the access to. And that's already 7 minutes. Okay, well, if this connects to the phone, then I'll show you the live demonstration. I'm going to give it a couple of minutes more to download the whole thing over the phone. Phone memory card connected. That doesn't look helpful. So I'm out of time, says Andy. Oh, yes, the app started. The app has started. I'm going to try and move this down so you get to see this on screen. There it is. Can you see? Not very easily. How's that? Vaguely.
Up a bit.
Up a bit? What do you about?
There.
And so that's that app which I just in less than 7 minutes. Well, okay. So, thank you all very much.